Hello everyone, this is Saurabh from Edureka. In today's session, we'll focus on what is Docker. So without any further ado, let us move forward and have a look at the agenda for today. First, we'll see why we need Docker. We'll focus on various problems that industries were facing before Docker was introduced. After that, we'll understand what exactly Docker is. And for better understanding of Docker, we'll also look at a Docker example. After that, we'll understand how industries are using Docker with a case study of Indiana University. Our fifth topic will focus on various Docker components like images, containers, etc. And our hands-on part will focus on installing WordPress and PHP MyAdmin using Docker Compose. So I hope you all are clear with the agenda. Kindly give me a quick confirmation by writing down in the chat box. So Ajay says yes. Pallavi, Stephanie, Daniel. Cool, great. So we'll move forward and we'll see why we need Docker. So this is the most common problem that industries were facing. As you can see that there is a developer who has built an application that works fine in his own environment. But when it reached production, there were certain issues with that application. Why does that happen? That happens because of difference in the computing environment between dev and product. So I hope we are clear with the first problem. Kindly give me a quick confirmation so that I can move forward. Or if you have any doubts or questions, do write it down in the chat box. I'll be very happy to help you. And I would like to add this thing, guys. Let us make this session interactive. You won't even enjoy it if it is a one-way conversation. So whatever doubts, whatever queries you have, please write it down in the chat box. All right, so shall I move forward? Just give me a confirmation. Pallavi says yes. So does Stephanie. All right, cool. I'll move forward and we'll see the second problem. Before we proceed with the second problem, it is very important for us to understand what are microservices. Consider a very large application. That application is broken down into smaller services. Each of those services can be termed as microservices. Or we can put it in another way as well. Microservices can be considered as small processes that communicates with each other over a network to fulfill one particular goal. Let us understand this with an example. As you can see that there is an online shopping service application. It can be broken down into smaller microservices like account service, product catalog, cart server, and order server. Microservice architecture is gaining a lot of popularity nowadays. Even giants like Facebook and Amazon are adopting microservice architecture. There are three major reasons for adopting microservice architecture, or you can say there are three major advantages of using microservice architecture. First, there are certain applications which are easier to build and maintain when they are broken down into smaller pieces or smaller services. Second reason is, suppose if I want to update a particular software or I want a new technology stack in one of my module or in one of my service, so I can easily do that because the dependency concerns will be very less when compared to the application as a whole. Apart from that, the third reason is if any of my module or any of my service goes down, then my whole application remains largely unaffected. So I hope we are clear with what are microservices and what are their advantages. Any questions, guys? Please write it down in the chat box. So we'll move forward and see what were the problems in adopting this microservice architecture. So this is one way of implementing microservice architecture. Over here, as you can see that there's a host machine, and on top of that host machine, there are multiple virtual machines. Each of these virtual machines contains the dependencies for one microservice. So you must be thinking, what is the disadvantage here? The major disadvantage here is in virtual machines, there is a lot of wastage of resources. Resources such as RAM, processor, disk space are not utilized completely by the microservice which is running in these virtual machines. So it is not an ideal way to implement microservice architecture. And I have just given you an example of 5 microservices. What if there are more than 5 microservices? What if your application is so huge that it requires 50 microservices? So at that time, using virtual machines doesn't make sense because of the wastage of resources. So any doubts still here, guys? Please write it down in your chat box. Any doubts? Shall I move forward and see how Docker is solving these problems? Cool, great. So I'll move forward. Thanks for the confirmation. So let us first discuss the implementation of microservice problem that we just saw. So what is happening here, there's a host machine, and on top of that host machine, there's a virtual machine. And on top of that virtual machine, there are multiple Docker containers, and each of these Docker containers contains the dependencies for one microservice. So you must be thinking, what is the difference here? Earlier we were using virtual machines, now we are using Docker containers on top of virtual machines. Let me tell you guys, Docker containers are actually lightweight alternatives of virtual machines. What does that mean? In Docker containers, you don't need to pre-allocate any RAM or any disk space. So it will take the RAM and disk space according to the requirements of applications. All right. Okay, so Stephanie has a question. She's asking, why are we using virtual machine here? Very good question, Stephanie. Let me tell you first, the host machine has to be a Linux or a Unix based machine in order to run Docker containers. Docker containers does not work on Windows system. So if you have a Windows system, you require a Linux or Unix virtual machine, then only you can run Docker containers. And one more reason for using Docker containers on a virtual machine is that you want to segregate it from the rest of the host machine. You want to encapsulate that separately in a virtual machine. Because in your host machine, suppose you have around 64 GB of RAM and around 20 TB of hard disk. And all of your microservices combined will not use more than 20 GB of RAM and 200 GB of hard disk. So there is no point on running Docker containers on the host machine. So I can configure a virtual machine that provides 20 GB of RAM and exactly 200 GB of hard disk, and I can run Docker containers on that virtual machine. So I hope this answers your question, Stephanie. Thank you for the confirmation. Now let us see how Docker solves the problem of not having a consistent computing environment throughout the software delivery lifecycle. Let me tell you, first of all, Docker containers are actually developed by the developers. So now let us see how Docker solves the first problem that we saw, where an application works fine in development environment but not in production. So Docker containers can be used throughout the SDLC lifecycle in order to provide consistent computing environment. So the same environment will be present in dev, test, and product. So there won't be any difference in the computing environment. So let us move forward and understand what exactly Docker is. So the Docker containers does not use the guest operating system. It uses the host operating system. Let us refer to the diagram that is shown. This is the host operating system, and on top of that host operating system, there's a Docker engine. And with the help of this Docker engine, Docker containers are formed. And these containers have applications running in them. And the requirements for those applications, such as all the binaries and libraries, are also packaged in the same container. All right. And there can be multiple containers running. As you can see that there are two containers here, 1 and 2. So on top of the host machine, there's a Docker engine. And on top of the Docker engine, there are multiple containers. And each of those containers will have an application running in them. And whatever the binaries and libraries required for that application is also packaged in the same container. So I hope we are clear. So now let us move forward and understand Docker in more detail. So this is a general workflow of Docker, or you can say one way of using Docker. Over here, what is happening? A developer writes a code that defines an application requirements or the dependencies in an easy to write Docker file. And this Docker file produces Docker images. So whatever dependencies are required for a particular application is present inside this image. And what are Docker containers? Docker containers are nothing but the runtime instance of Docker image. This particular image is uploaded onto the Docker Hub. Now what is Docker Hub? Docker Hub is nothing but a Git repository for Docker images. It contains public as well as private repositories. So from public repositories, you can pull your image as well, and you can upload your own images as well onto the Docker Hub. All right. From Docker Hub, various teams such as QA or production team will pull the image and prepare their own containers, as you can see from the diagram. So what is the major advantage we get through this workflow? So whatever the dependencies that are required for your application is actually present throughout the software delivery lifecycle. If you can recall the first problem that we saw, that an application works fine in development environment, but when it reaches production, it is not working properly. So that particular problem is easily resolved with the help of this particular workflow, because you have a same environment throughout the software delivery lifecycle, be it dev, test, or product. So I hope I'm clear. Are there any doubts still here? Okay, so Daniel has a question. He's asking, can you please elaborate more on Docker Hub? Sure, Daniel. Docker Hub is basically a cloud hosted service provided by Docker. Over here, you can upload your own images, like you can write your own image and upload that onto the Docker Hub. And at the same time, you can even pull the images that are present in the public repositories. All right. So it is just like a Git repository for Docker images. Are you clear with Docker Hub, Daniel? Give me a quick confirmation so that I can move forward. Thank you. Thanks a lot for your confirmation. So I'll move forward and we'll see, for better understanding of Docker, a Docker example. So this is another way of using Docker. In the previous example, we saw that Docker images were used and those images were uploaded onto the Docker Hub. And from Docker Hub, various teams were pulling those images and building their own containers. But Docker images are huge in size and requires a lot of network bandwidth. So in order to save that network bandwidth, we use this kind of a workflow. Over here, we use Jenkins servers or any continuous integration server to build an environment that contains all the dependencies for a particular application or a microservice. And that build environment is deployed onto various teams like testing, staging, and production. So let us move forward and see what exactly is happening in this particular image. Over here, developer has written complex requirements for a microservice in an easy to write Docker file. And the code is then pushed onto the Git repository. From Git repository, continuous integration servers like Jenkins will pull that code and build an environment that contains all the dependencies for that particular microservice. And that environment is deployed onto testing, staging, and production. So in this way, whatever requirements are there for your microservice is present throughout the software delivery lifecycle. So if you can recall the first problem where application works fine in dev but does not work in prod. So with this workflow, we can completely remove that problem because the requirements for the microservice is present throughout the software delivery lifecycle. And this image also explains how easy it is to implement a microservice architecture using Docker. Now let us move forward and see how industries are adopting Docker. So this is the case study of Indiana University. Before Docker, they were facing many problems. So let us have a look at those problems one by one. The first problem was they were using custom script in order to deploy their application onto various VMs. So this requires a lot of manual steps. And the second problem was their environment was optimized for legacy Java-based applications. But their growing environment involves new products that aren't solely Java-based. So in order to provide their students the best possible experience, they needed to begin modernizing their applications. Let us move forward and see what all other problems Indiana University was facing. So in the previous problem of Indiana University, they wanted to start modernizing their applications. So for that, they wanted to move from a monolithic architecture to a microservice architecture. And the previous slides, we also saw that if you want to update a particular technology in one of your microservice, it is easy to do that because there will be very less dependency constraints when compared to the whole application. So because of that reason, they wanted to start modernizing their application. They wanted to move to a microservice architecture. Let us move forward and see what are the other problems that they were facing. Indiana University also needed security for their sensitive student data such as SSN and student healthcare data. So there are four major problems that they were facing before Docker. Now let us see how they have implemented Docker to solve all these problems. The solution to all these problems was Docker Data Center. And Docker Data Center has various components which are there in front of your screen. First is Universal Control Plane, then comes LDAP, Swarm, CS Engine, and finally Docker Trusted Registry. Now let us move forward and see how they have implemented Docker Data Center in their infrastructure. This is a workflow of how Indiana University has adopted Docker Data Center. This is Docker Trusted Registry. It is nothing but the storage of all your Docker images. And each of those images contains the dependencies for one microservice. As we saw that Indiana University wanted to move from a monolithic architecture to a microservice architecture. So because of that reason, these Docker images contain the dependencies for one particular microservice, but not the whole application. All right. After that comes Universal Control Plane. It is used to deploy services onto various hosts with the help of Docker images that are stored in the Docker Trusted Registry. So IT Ops team can manage their entire infrastructure from one single place with the help of Universal Control Plane web user interface. They can actually use it to provision Docker installed software on various hosts and then deploy application, so without doing a lot of manual steps. As we saw in the previous slides that Indiana University was earlier using custom scripts to deploy application onto VMs. That requires a lot of manual steps. That problem is completely removed here. When we talk about security, the role-based access controls within the Docker Data Center allowed Indiana University to define a level of access to various teams. For example, they can provide read-only access to Docker containers for production team, and at the same time, they can actually provide read and write access to the dev team. So I hope we all are clear with how Indiana University has adopted Docker Data Center. Do you have any questions, any doubts still here? Please ask me. So Pallavi has a question. She's asking, what is the difference between Docker containers and virtual machines? So Docker containers are nothing but the lightweight alternatives of virtual machines, as I've told you earlier as well. Docker containers don't have their own operating system. They sit on top of the host operating system, or you can say that they uses the host operating system. In Docker containers, you don't need to pre-allocate any RAM. It takes the RAM accordingly, but in virtual machines, you have to pre-allocate a certain amount of RAM. When we talk about runtime, Docker containers have very less runtime because you don't need to boot the OS. Whereas in virtual machine, it has a runtime which is greater than Docker containers because you need to boot the OS. So these are the three major differences. If you want to know more difference between Docker containers and virtual machines, you can refer to the Docker tutorial video. So I hope you are clear with the differences between Docker containers and virtual machines. Is there any doubt in your mind? Please ask. Anyone, if you have any doubts, please ask so that we can proceed towards various Docker components. So cool, we'll move forward and see what are the various Docker components. First is a Docker registry. Docker registry is nothing but the storage of all your Docker images. Your images can be stored either in public repositories or in private repositories. These repositories can be present locally or it can be present on the cloud. Docker provides a cloud hosted service called Docker Hub. Docker Hub has public as well as private repositories. From public repositories, you can actually pull an image and prepare your own containers. At the same time, you can write an image and upload that onto the Docker Hub. You can upload that into your private repository or you can upload that on a public repository as well. That is totally up to you. So for better understanding of Docker Hub, let me just show you how it looks like. So this is how Docker Hub looks like. So first you need to actually sign in with your own login credentials. After that, you'll see a page like this which says welcome to Docker Hub. Over here, as you can see, that there is an option of create repository where you can create your own public or private repositories and upload images. And at the same time, there's an option called explore repositories. This contains all the repositories which are available publicly. So let us go ahead and explore some of the publicly available repositories. So we have repositories for Nginx, Redis, Ubuntu, then we have Docker registry, Alpine, Mongo, MySQL, Swarm. So what I'll do, I'll show you a CentOS repository. So this is the CentOS repository which contains the CentOS image. Now what I'll do, later in the session, I'll actually pull a CentOS image from Docker Hub. Now let us move forward and see what are Docker images and containers. So Docker images are nothing but the read-only templates that are used to create containers. These Docker images contains all the dependencies for a particular application or a microservice. You can create your own image and upload that onto the Docker Hub, and at the same time you can also pull the images which are available in the public repositories and in Docker Hub. Let us move forward and see what are Docker containers. Docker containers are nothing but the runtime instances of Docker images. It contains everything that is required to run an application or a microservice. And at the same time, it is also possible that more than one image is required to create one container. Alright, so for better understanding of Docker images and Docker containers, what I'll do on my Ubuntu box, I'll pull a CentOS image and I'll run a CentOS container in that. So let us move forward and first install Docker in my Ubuntu box. So guys, this is my Ubuntu box. Over here, first I'll update the packages. So for that, I'll type sudo apt-get update. So asking for password. It is done now. Before installing Docker, I need to install the recommended packages. So for that, I'll type sudo apt-get install linux-image-extra uname space -r, and now a linux-image-extra-virtual, and here we go. Press Y. So we are done with the prerequisites. So let us go ahead and install Docker. So for that, I'll type sudo apt-get install docker-engine. So we have successfully installed Docker. If you want to install Docker and CentOS, you can refer the CentOS Docker installation video. Now we need to start this Docker service. So for that, I'll type sudo service docker start. So it says the job is already running. Now what I'll do, I'll pull a CentOS image from Docker Hub and I'll run the CentOS container. So for that, I'll type sudo docker pull and the name of the image, that is CentOS. So first it will check the local registry for CentOS image. If it doesn't find there, then it will go to the Docker Hub for CentOS image and it will pull the image from there. So we have successfully pulled a CentOS image from Docker Hub. Now I'll run the CentOS container. So for that, I'll type sudo docker run -it CentOS, that is the name of the image, and here we go. So we are now in the CentOS container. Let me exit from this, clear my terminal. So any doubts still here, guys, you can ask me by writing down in the chat box. Any doubts, any questions, please ask me. I'll be very happy to help you. All right, no doubt. So I'll move forward with the slides. Just give me a quick confirmation. Thanks, Stephanie, Pallavi, Daniel. Cool, great, we'll move forward. So let us now recall what we did. First, we installed Docker on Ubuntu. After that, we pulled CentOS image from Docker Hub. And then we built a CentOS container using that CentOS image. So are we clear? Now I'll move forward and I'll tell you what exactly Docker Compose is. So let us understand what exactly Docker Compose is. Suppose you have multiple applications on various containers, and all those containers are actually linked together. So you don't want to actually execute each of those containers one by one, but you want to run those containers at once with a single command. So that's where Docker Compose comes into the picture. With Docker Compose, you can actually run multiple applications present on various containers with one single command, that is docker-compose up. As you can see that there is an example in front of you. Imagine you're able to define 3 containers, one running a web app, another running a Postgres, and another running a Redis in a YAML file. That is called Docker Compose file. And from there, you can actually execute all these 3 containers with one single command, that is docker-compose up. Let us understand this with an example. Suppose you want to publish a blog. For that, you'll use CMS. And WordPress is one of the most widely used CMS. So you need one container for WordPress, and you need one more container for MySQL as backend. And that MySQL container should be linked to the WordPress container. Apart from that, you need one more container for PHP-MyAdmin that should be linked to MySQL database, as it is used to access MySQL database. So what if you are able to define all these 3 containers in one YAML file, and with one command, that is docker-compose up, all 3 containers are up and running. So let me show you practically how it is done on the same Ubuntu box where I've installed Docker and I've pulled a CentOS image. So this is my Ubuntu box. First, I need to install Docker Compose here. But before that, I need Python pip. So for that, I'll type sudo apt-get install python-pip, and here we go. So it is done now. I will clear my terminal and now I'll install Docker Compose. For that, I'll type sudo pip install docker-compose, and here we go. So Docker Compose is successfully installed. Now I'll make a directory and I'll name it as WordPress. mkdir WordPress. Now I'll enter this WordPress directory. Now over here, I'll edit docker-compose.yaml file using gedit. You can use any other editor that you want. I'll use gedit. So I'll type sudo gedit docker-compose.yaml, and here we go. So over here, what I'll do, I'll first open a document and I'll copy this YAML code and I will paste it here. So let me tell you what I've done. First, I've defined a container and I've named it as WordPress. It is built from an image WordPress that is present on the Docker Hub. But this WordPress image does not have a database. So for that, I've defined one more container and I've named it as WordPress_DB. It is actually built from the image that is called MariaDB, which is present in the WordPress. And I need to link this WordPress_DB with the WordPress container. So for that, I've written links WordPress_DB:/MySQL. All right. And in the port section, this port 80 of the Docker container will actually be linked to port 8080 of my host machine. So are we clear till here? Now what I've done, I've defined a password here as Edureka. You can give whatever password that you want. And I've defined one more container called phpMyAdmin. This container is built from the image corbinu/docker-phpMyAdmin that is present on the Docker Hub. Again, I need to link this particular container with WordPress_DB container. So for that, I've written links WordPress_DB:/MySQL. And the port section, the port 80 of my Docker container will actually be linked to port 8181 of the host machine. And finally, I've given a username that is root and I've given a password as Edureka. So do you have any doubts, any questions? Please write it down in your chat box. Okay, so Ayushi is asking, can you please repeat it once more? Sure, Ayushi, I'll do that. So what I've done here, I have defined a container by the name WordPress. It is built from an image called WordPress that is present in the Docker Hub. All right. But this image that is present in the Docker Hub does not have a database. So I need to define one more container that contains a database. So WordPress_DB is the name of that container, and it is built from an image called MariaDB, which is present on the Docker Hub. Now, as I've told you earlier as well, so I need to link this database with WordPress. So what I'll do, I'll write links WordPress_DB:/MySQL. All right. And the port section, the port 80 of the Docker container will be linked to port 8080 of the host machine. After that, we require one more container and I've named it as phpMyAdmin. It is built from the image called corbinu/docker-phpMyAdmin. And I need to link this particular container with WordPress_DB, and MySQL is actually the name that I've given. In the port section, the port 80 of the container is actually linked to port 8181 of the host machine. And finally, I've given username and password. I've given username as root and password as Edureka. You can give whatever password or username that you want. So let us now save it and we'll quit. Let me first clear my terminal. And now I'll run a command sudo docker-compose up-d, and here we go. So this command will actually pull all the three images and will build the three containers. So it is done now. Let me clear my terminal. Now what I'll do, I'll open my browser. And over here, I'll type the IP address of my machine, or I can type the host name as well. Host name of my machine is localhost. So I'll type localhost and port 8080 that I've given for WordPress. So it will direct you to a WordPress installation page. Over here, you need to fill this particular form, which is asking you for site title. I'll give it as Edureka. Username also, I'll give as Edureka. Password, I'll type Edureka. confirm the user weak password, then type your email address, and it is asking search engine visibility, which I want, so I won't click here. And finally, I'll click on install WordPress. So this is my WordPress dashboard, and WordPress is now successfully installed. Now what I'll do, I'll open one more tab, and over here I'll type localhost or the IP address of my machine, and I'll go to port 8181 for phpMyAdmin. And over here I need to give the username. If you can recall, I've given root, and password I've given as Edureka, and here we go. So phpMyAdmin is successfully installed. This phpMyAdmin is actually used to access a MySQL database. And this MySQL database is used as backend for WordPress. Thank you for attending today's session. Thank you and have a great day.